Welcome to the Advanced Automation Lab. Today, we are moving beyond simple switches to master the backbone of modern factories, the automated conveyor system. In this experiment, you will learn how a PLC, an HMI, and IIoT work together to create an intelligent material handling process. Think of the PLC as the brain. It waits for a start signal, then commands the motor to move. When a sensor detects a box, the brain sees this and immediately decides to stop the line. It's a perfect loop of sensing, thinking, and acting. But we aren't just controlling it locally. Through the HMI, you interact with the machine in real time, while IIoT sends every start and stop event to the cloud for global monitoring. The secret to success is the PLC scan cycle. Even while the belt moves, the PLC is checking its inputs and logic thousands of times per second. This ensures that the moment a box is detected, the motor stops without a millisecond of delay. Before we begin, ensure your MCB is on, the emergency stop is released, and your PLC and PC are communicating on the correct IP range. Ready to automate? Let's head to the workstation.
Hello everyone, today I'll explain Advanced PLC Workstation with IoT and HMI with PLC. So this workstation works on Mitsubishi. So Mitsubishi PLC is manufactured by Mitsubishi Electric. So why we use this one? Because it's a reliable, easy to program and faster. So here I'll introduce about this kit. So here we can see the input cards. So these are in PLC inputs, digital inputs and analog inputs are there. Here we can see physical inputs. We have to connect these digital inputs to the physical inputs. Again here we can see the digital sensor modules. Again different types of sensors are there here. So inductive sensor, you already know what is inductive sensor. Inductive sensor will detect the metals, and here again NC option is also there. We can use capacitive sensor also to detect all type of objects, and photo sensor works on the light.
Observe, the trainer just showed you 3 types of sensors. Why? Because choosing the wrong sensor causes the whole system to fail. Inductive sensors only detect metal. If your conveyor is moving plastic boxes, an inductive sensor will be blind to them. You must use the capacitive or photo sensor for non-metals. Always match your sensor to the material.
So here we can see the physical buttons. Those are push buttons, selector switches and emergency switch buttons, indicators and buzzers. Indicators are buzzers used for outputs, and these buttons all used for inputs. Here we can see this is HMI screen, and here you can see the cards. These are called as cards. These will be placed on one rack. Okay. First card is our power supply card. Power supply you already know, it will give the supply to the main station. Then this is our main PLC CPU. CPU works as a brain of the station.
Warning. Let's talk about safety before we go further. The power supply card feeds the CPU. Never reverse the polarity of the incoming voltage. If you accidentally connect the 24 volts to the 0 volt terminal, you will instantly fry the PLC's internal motherboard. Always double check your positive and negative wires before turning the main power on.
Then here you can see input and output cards. Input and output cards receives from the input card will receive from the push button signal, and output card will actuate the signal. So here we can see outputs. That outputs will be connected to others like indicators. You can also see buzzers also you can connect, and here we have pneumatic cylinders. These are called as pneumatic cylinders or solenoid valves. So this is all about the workstation. So for Mitsubishi PLC we are using GX Works3 software. So here you can see the blank screen. Go to new project, click on new. Then here you can see RCPU and R04EN. You have to see whether it is there or no, and the ladder type program. Say OK. Now it has created a new project. Say just OK here. And in the left side corner you can see module configuration here. Just double click on that. Say OK. So this empty screen is visible now. So go to online and just click on read module configuration from PLC. Say yes. So your whole PLC kit is visible now here. So now just go to program body, double click. Here you can see the ladder blank one. So here double click on first one, just select NO or NC, whichever input. Here input starts from X20, so I am giving it as a X20. You can also tag it. So I'll name it as a start button. Say OK. Then one more NC we are using, that is X21. So I'll name it as stop button. Say OK. And one more we have to use is sensor. So sensor will be again NC X22. This will be called as endpoint sensor. Just say OK. And the output starts from Y40 here. So I am choosing a coil and mentioning it as Y40. Say OK. So we have to do the latching now here. So for latch purpose again NO with the latch, that we can mention it as Y40. So here your program is done. So after this you have to go to convert B. Convert B in the sense it will save the program. Now go to rebuild all and say OK. Rebuild all is nothing but compiling. Now just go to online, write to PLC, say yes. Just click on OK. One more time OK. So here select all and execute. Say yes to all. So say just close the window. So here your PLC program is done. So if you want to check whether it is correct or no, just go here, start simulation, click on start simulation and go to online, monitor mode on. So you can press it physically and check whether the output is coming or no. So your Y40 output is on. Again go to online, monitor, just right mode पे shift हो जाओ. Just say OK to that. Now we have to design HMI for this screen. So we'll go to GT Designer 3, one more software for HMI. New, next. So here you can see you have to choose GS series in the series. Next, say next. Mitsubishi Electric is there, IQR series. Next, say next to all the options. And here you can choose one design to your screen or color. So in the right side corner you can see there are switches. So you have to choose bit switch here. So we have here 3 inputs in our program. So I am copying it for the 2 times. Just drag and drop. Now go to lamp option, take bit lamp and draw it here. So now I have coming to addressing. So click on first switch and device address will be your PLC address. And here you can change the style also. When it is in off condition, it will be in red color. When it is in on condition, it will turn to green. So text also you can give. This is a start button. Coming to next switch, select on next switch. Here you can give X21 and style, change it to colors, whichever color you want. This is our stop button. So sensor will be also like a switch. So X22. I am changing the style. So text I'll give it as a end point sensor. So coming to lamp, you have to give the address as Y40. Again for off condition it will be red color in red. So on it will turn to green. So after finish, go to communication. Here you can see communication configuration. There you have to choose here Ethernet and test whether the communication is possible or no. If it shows successfully connected, then say OK. Again come to communication, write to GOT. Here Ethernet option is there and say OK. Just say here GOT, write. Don't cancel it up to completion. So communication is, data transfer is successfully done. Say OK. So your screen is visible in on HMI screen. Just now we wrote the program for conveyor model. So we wrote the program on this. When we press the start button, the conveyor will start moving, and when we want to manually stop it, we can stop with this button.
Supervisor note on safety. The trainer mentions stopping the conveyor manually. In a real industrial factory, normal stop buttons are not enough. You must wire an emergency stop or e-stop. Normal stops rely on the PLC program, which can glitch. An e-stop physically breaks the electrical circuit. If a worker's hand gets caught, the e-stop is what saves their life.
And when we are don't want to stop it manually and it should be stopped by sensor, endpoint sensor, then that time also it will stop the conveyor. So this is the model for that. Now we'll see the connection for this one. So here we can see 24 volt ground both are there. So 24 volt and ground will be given from this side. So input and outputs will be given from the PLC. So here we can see we have to take out the wires. So just give the first 0 volt ground to here 0 volt. The one connection is done. Now take out one more wire. Give the 24 volt supply from this side. This is 24 volt. Here we can see 24 volt and 0 volt. So my first input is conveyor start. So in the PLC program I gave it as address X20. So here is my X20. So I am giving here the connection. Second one is my input stop button. So that in PLC I gave it to X21. So I am giving the connection to X21. So last one is input side, that is endpoint sensor. Again in PLC it is X22. So the connection is given to the X22. Here we can see 3 inputs are already given. So one more we are left, that is our output. So our output is conveyor motor, that is in the PLC it is Y40. Addressing is Y40. So I am connecting it to the Y40.
Let's pause and understand the logic here. Why did she connect the buttons to X and the motor to Y? In Mitsubishi PLCs, X always stands for physical inputs, like your sensors and switches. Y stands for outputs, like motors and buzzers. If you wire a 24-volt motor directly to an X input terminal by mistake, you will destroy the input card. Keep your inputs and outputs strictly separated.
So now we can see the working. So when I press start button, our conveyor on. So when I press start button, the motor is on, even it is reflecting on the HMI screen also. Here you can see. And when I want to stop it, I'll press sensor, our motor is off. Here it is reflecting in the HMI also. Even we can work through this one. HMI pe start kiya, then it is showing on the conveyor motor on the static module also. If I want to stop from here, it is showing on the HMI also.
Final concept check. You just saw the motor start from the HMI screen and the physical push button. This is the magic of SCADA and HMI integration. The screen communicates directly with the PLC's memory over a network. But remember the golden rule. HMI screens can freeze. Never rely purely on a touchscreen for emergency safety stops. Always have a hardwired physical switch on the panel.
This is how we control with the screen, the static module.